Hello everyone, our team presents to you Motor Vehicle Collision Data Analyzing Web Application. We are mentored by Professor Amaya Parkar. Our web app uses data analysis techniques to analyze collision data. Our objective was to develop a data science web app that provides data analyzing techniques to load, explore, visualize, and interact with data. Moving over to the technical stack used, Streamlit. Streamlit is an open source Python library. It allows you to create a stunning looking application with few lines of code. Numpy. Numpy is a Python library used for working with arrays. Numpy aims to provide an array object that is up to 50 times faster than traditional Python lists. Plotly. Plotly Python library is an interactive open source library. It is used for data visualization and understanding the data simply and easily. It can plot various types of graphs and charts. Pandas. Pandas stands for Python Data Analysis Library. Pandas takes data like .csv file in our case and creates a Python object with rows and columns called data frame that looks very similar to table in a statistical software. Now let's move to the project demonstration. As our application relies on a CSV file to convert data into graphical representations, this is the CSV file used, which holds approximately 8 lakh records and is acquired from NYC Open Data. From the application dashboard, we summarize there is a map followed by a slider along with a certain query. The first query handles the location where most people are injured in New York City. The slider has a range from 0 to 20, which when interacted with helps us to show the location in red dots over the map where people are injured. Let's say we move the slider to 3. From the map we can now see the various locations where at least 3 people are injured in vehicle collisions. The map loads data from the CSV dynamically when we use the slider to display the appropriate information. The map can be viewed in 2D plane fashion as well as at a tilted angle, giving it a 3D look. Coming up next is the second query, which shows the data on the number of collisions occurred during a given time of the day. The slider here gives us a range of 0 to 24, which depicts the number of hours in a day. We can view how many collisions have occurred at a certain hour in the day by moving the slider across the screen and choosing a certain hour. Example, 8 a.m. And now we can see the locations in the map in the form of red bars. The histogram underneath the map gives us the minute by minute representation of the collisions occurred along with the count. Further on, we have implemented a bar graph which represents the types of vehicles involved in accidents along with the vehicle count. Upon maximizing the graph, we can notice certain features available due to Plotly library, such as the box select tool, which helps select certain bar graphs and grays out the remaining ones. The zoom in and zoom out feature to zoom into graphs, and the reset axis option to reset the graph back to its original scale. The toggle spike lines option toggles a spike line which runs perpendicular to both axes over a bar and gives us the exact highest coordinates of the selected bar in the graph. Compare data on hover and show closest data on hover. Both options allow us to view coordinates on mouse over. Moving ahead, we have a grid layout which gives information on streets infamous for collisions. There is a drop down with affected type of people such as cyclists, pedestrians, and motorists. Upon selection of one type, the grid layout updates itself with street names sorted according to the most injured personnel depending on the type chosen. We have also included an option to check raw data, that is the raw CSV format in a grid layout. In conclusion, this project has achieved its goal to visualize the raw table format data recorded in CSV files and present it to the viewer in an interactive manner using maps which represent actual location and correspond to the data, thus allowing the viewer to gain more information. Along with graphs and interactive sliders, the user can view the data presented to them with more controls on their side, without any hassle and with less time consumption to load the data at the same time. Thank you for the opportunity given to present our project.